Okay, members, today we are going to see what we call the ratio theorem, or some people call it the section formula. Why is it called the section formula? We are going to see. Now, this ratio theorem says if we consider point P which divides a line segment AB in the ratios of lambda to mu. So it's that I have a line segment AB. Now I have a point P which divides it in the ratios of lambda to mu. So that means that the ratio of AP to PB is lambda to mu from here. Meaning that we can always convert ratios into fractions. So if I convert as a fraction like that, then I cross multiply. Cross multiplying, I have this times this to get mu AP equaling to lambda times PB to get this. But you know, if I have AP, I can get it as OP minus OA equaling to lambda OB minus OP in that order. Now from there, after I open brackets, this lambda times this and this and this together, the same case beside. Now I want to know the position vector, the position vector of this point that is dividing this line, this point P. So I make it a subject by taking OP this side. When I take this side, I take now this one, the other side. Now you see that I have now OP common. When I factorize it OP, I have lambda plus mu here equaling to that side. Then if I make OP the subject, is that I'll be having now lambda this plus this over this side. And members, this is what we call the section formula of the ratio theorem. Formula. Now from here you see, if I have a point A, lambda, then mu, and a point B, it means that to get OP, all we do, you get this first ratio times the last, I think you see, times the last position vector of this coordinate. Then this one times the first of the first position vector of the first coordinate. So see me times this. So always this will multiply this, the ratio this will multiply this, and this ratio will always multiply that in that order. Then over the sum of the two. Let us see this example. Find the coordinates of a point P, so the one the coordinates of point P, which divides a line joining the points A and B. So this point is B. So which divides it in the ratios of 2 to 1. It means that now using the ratio theorem, you know that our ratio theorem is going to be always OP equaling to, we said if in that order, this one is called lambda, this one is called mu. So it's always lambda, this lambda times this, the position vector of the last point, which is OB, then plus this, the second ratio times the position vector of the first coordinate over the sum of those coordinates. So from there, we are just substituting. So now my OP is going to be, now lambda, my lambda is 1. My lambda is 2 into now the position vector of OP. OP is here as negative 8, 2, 4 in brackets, then plus mu. My mu is 1, then times the position vector of this first coordinate, which is 1 to negative 1, then the whole divided by lambda plus mu, which is the sum of these ratios, 1 plus that. So from there, as you see, we multiply, and this is what we get. You see one, okay, this will be negative 16, this times this, 4, 8. Then plus, when you multiply here by 1, you get the same thing. 1 to negative 1. The whole over 3. So you see that when I put this one, my OP, I can pull out this one, and you see that it will be a third. When I pick this one out, when I pull it out, it will be 1 over 3 in the brackets. Now I add negative 16 plus 1, negative 15. 4 plus 2, that is a 6. Then 1 plus negative 1, 8 plus negative 1, that would be 7. If I multiply now this, so I'll be having now my OP as 5 times this. You see that we are just dividing this by 3, by 3, by 3. Or 5 times this, we get negative 5. We get 2. So this one doesn't count, so it remains 7 over 3. But remember, they asked for a coordinate. This is the position vector. If now we want the coordinate, we write it in a coordinate system. It will be now the x is negative 5, the y is a 2, then the z is 7 over 3. So members, that's how we use the ratio theorem. Don't forget to subscribe to the channel. Even if this was 3 to negative 2, you just put this will be 3, this will be negative 2. You add them, then this will multiply the last, and then this will multiply the first. As simple as that. Don't forget to subscribe to the channel. I wish you the best.